So the next talk, so Rob Basham, he came up two years ago.
It's been just a year, and I had a great time last year, and actually had a key breakthrough while speaking at this conference last time. And so I always like coming to London, and looking forward to my presentation. Thanks for having me. You know, we've been very busy. We've actually delivered quite a bit since last year. You know, last year about this time we were talking about worm support, and maybe just a quick review on what transparent cloud tiering is. Tiering is the ability to tier data natively to object storage. So, you know, we can set up a policy, ILM policies, to migrate data to the cloud, and then transparently, as data is accessed and be pulled, it's typically used for cooler data. You know, obviously you don't want to have data that you're, you know, modifying and, you know, it's really hot going out there deleting because, you know, object storage, that's just not how it works. Doesn't work really well for that sort of traffic. But if you have storage that is cooler, you know, there is definitely interest in, and we have several customers now that are using this for their cooler data. We also released the ability to share data with the cloud. So sharing is the ability to, if you have data that originates in the cloud, you can import that data into Scale through this feature. Of course, you can go either direction. So if you want to share data with native object storage applications, you can write ILM policies again and just export the data based on the policy. So these were things that were around last year and what I've talked about. So this is a quick review. And, you know, we've added worm support. We've added pre-migration where you can have the data in both places. And those were things that we've had around for a while. Let me talk about what's in 5.0. So with 5.0, we really didn't work on performance much. And just kind of give you a rule of thumb for performance. You can think about this as something where you can move a petabyte or two a week, right? So if you need to do more than that, you're probably stretching this function in object storage for that matter. You know, object storage isn't big at necessarily moving a lot of data, but so about a petabyte or two a week. But we did do some things to scale this. So, you know, what I would say is with what we've done here, where we've added in support for files, multiple file systems, file sets, and with container spillover, we're up to around comfortably, you know, in the low tens of billions of files. So if you want to transfer low tens of billions of files, we're there. And you know, if you're interested in doing more like 100 billion, come talk to me afterwards. Let's talk. And in addition to that, we've added in remotely mounted client support, which of course with ESS is very important because that's a very common way to use ESS is through remotely mounted clients. So, you know, with this, we've really, you know, added in this scalability. We also added in multiple tiers in the cloud. So we had some customers that wanted to do a cool tier and a cold tier. And so they said, well, wait a minute, I want to do my cool tier on-prem, but when I get off-prem, I want that data for cold tier. We added in that support in 5.0. So these are all things we were talking about with an Outlook last year, and we've delivered those now. And you know, so you can get a topology, you know, on here with these multiple node classes talking, where you might have one node class talking externally to your external object storage, and one internally. This, for example, you see the purple and red node classes here. And then you see a remotely mounted node class. This might be a more complicated cluster. Let me tell you about just typically what our customers say. They say, Rob, your migrations are fine. You know, if you can do a petabyte or two a week, you're fine. You know, I'm good with that. But when we talk about recall, they say, you know, I'm not sure what my recall needs are even going to be. You know, I have umpteen hundred users and I'm not sure when they recall data, day or night. And so you may get recall storms. And so, you know, if you do the math on, you know, 1 or 2 petabytes a week, that's, you know, that's a low gigabytes a second. And they say, well, you know, I'm not sure, you know, if that's going to work. So one of the things, and this came out of this conference, there was actually a gal that did a presentation on how she had put her networking enablement on every single cluster. I said, we could do that for TCT. And we did. It's not in 5.0 or even in 5.0.1, but the feature is done and functionally tested. It's in systems test now. We call it direct client access. So what you can do is for recall from every node in your cluster, you can now directly do your transparent recalls. So what this means is you have a 1,000 node cluster, you have 1,000 nodes that can directly access your object storage. You know, what's really cool here is I have a customer right now who has set up their IBM Cloud Object Storage with an accessor node on every single node in the cluster. So if you're familiar with Cloud Object Storage, this is a new feature there. So that basically now they have accessor nodes on every node in their object storage, and they have the ability from the client to request that data. Now that this whole bottleneck of recalls, we're just exploding it, right? So now it's completely scalable, and it scales with the size of your cluster. What this means is, I used to show in big bold letters, do not use this to back up your data, right? The reason being is you have a bottleneck on your recall. Well, with this, if you're willing to set up a flat sort of network and you have a big enough object storage cluster with a lot of access or power, you can use TCT for restoring your data. This is something, this is now going to be possible. And like I said, we're done with the functional test on it. Hasn't been systems tested yet, and the outlook would be for later this year. This is something we're working on. Let me talk about 5.0.1. I just had to bring that up because the idea came right here in this meeting. So, the other things we're doing that we're doing right away in 5.0.1 is we've added in service restoration using SOBAR. So SOBAR is a feature that's been around in spectrum scale forever, and it's a nice little snapshot restore feature. With it, we can do it's on the order of 1 million files a minute restore. So it's fast. So you know, if you have a problem on your cluster where you like a complete site kind of disaster, you can now restore your service in about a day per billion files. And we will add that. We have we've added in an automated maintenance scheduling. So there is some maintenance with TCT, things like backing up your cloud database, things like reconciling your cloud data with your file system data. We've added all that so it's automated in background. You don't have to schedule your cron jobs anymore. We do that for you. And we set maintenance windows, background maintenance windows. You can change those, you know, 1 a.m. to 4 a.m. and on Saturdays are the standard maintenance windows, but you can move them whenever. We've also added in, you know, some improved, you know, metrics and some other things to help with service and support. Yeah, Simon.
Can I ask a quick about SOBAR? So by default, is it like 2 meg files that get to the cloud? How does that work with SOBAR? Do you tier everything out anyway?
So here's the deal. Object storage just does not do really well with small files, and but we support it. And so what SOBAR does, what we do with SOBAR is, you know, it is about backing up the inodes. And when you back up the inodes, it all gets tarred into a big, huge file. So by the time it hits object storage, it's a huge multi-gigabyte file is what the SOBAR file that the object storage sees. But actually, if you look at what we do, we store our metadata in very small files in the cloud, and it works just fine. It's just again, it's a performance issue. If your mix of files is really small, you're not going to get great performance. Again, it's an IOPS rate challenge for object storage. Good question, thanks. But we have people. This is just coming out, and we have people looking forward to this. I would say, if you have a single site and you have any worries about, the DR or whatever for your data, I would definitely recommend picking up SOBAR when it comes out in 5.0.1. Okay, probably the hardest thing we did, and I would say in many ways the most exciting was, again, we're working on recall. And what we've done is we've already had parallel threading for recalls, but what we've done is we've expanded it so that parallel threading is within an individual large file. So it used to be if you had like a multi-gigabyte file, we're pulling it in on a single thread and it's taking, at object storage speeds again. So if you understand how object storage works, it works very well in huge, massive parallel threads. But if you go on a per thread basis, it's slow. And that's just object storage the way it is. So by multi-threading large individual files on the part boundaries, for those of you who understand object storage, that's how it works on parts, then it's on the order of a magnitude faster. Your latency is going to be better. So look for that coming up. Okay, so we've kind of talked about functions and features, and now I'm kind of want to turn it over to you. I want to talk to you about something we are working on for the future, and I wanted input on. So it's Kafka based. We're taking Kafka and we're going to use Kafka to support multi-cluster, multi-site. So if you understand object storage, one of its strengths is multi-site. It does site distributed erasure coding. So, the more sites, the more efficient it gets in terms of storage efficiency. And also, you get, some interesting redundancy and resiliency characteristics. So, using this Kafka message bus, which Scale already has, we've heard some talk about that from Matthias earlier. We're taking that message bus and we are using it to communicate with remote sites. And in doing so, we are able to, in near real time, have a consistent message space and share that data across all your clusters. And you'd say, well, Rob, how is this different than AFM? It's not. It's a different animal than AFM. This is much more loosely coupled. This is something that you could envision doing between companies, for example. Like, let's say you had a university, right? And you were a company and you're sharing data. You could have your data's off in some cloud service like, SoftLayer or Amazon. Your data's there. And the only thing you're kind of exchanging is Kafka events between the sites. It's a more loosely decoupled service. We also envision in the future that we could use the architecture such that if we use the object storage events, that would be 100% efficient. There would be no need ever for the two clusters to talk to each other. What this means is, in theory, is you could have heterogeneous file system types. Like you could envision that sharing data between Spectrum NAS, which is a new IBM product, right, and Spectrum Scale, where they would be sharing data. So it's much more loosely decoupled than AFM. AFM is scale to scale, right? mean, this works scale to scale too, and we're starting with scale to scale, but we're working on a much more decoupled architecture to allow for heterogeneous sharing and more loosely decoupled, like company to company type sharing in that respect. So that's kind of the nature of the beast. So let's start with some of the, maybe some of the things, and I'm trying to get a feel for here what to, if we got this dialed in right for our first release. So from a sharing paradigm perspective, what you can share is you can share like a file set with another site and set up the file set along with an ILM policy. So you don't have to share everything in the file set, but you choose what by ILM policy you want to share with the other site. So you could filter, so to speak. You could share everything, of course, right? Or you could share less than that. You filter by ILM policy to say, this is the stuff I want to share. So you have one site that the writer, and then you could have N other sites that would be the reader. So think of this as like a single writer, multi-reader service in general. Now, multi-cluster writes, is it possible? Yes, but I'm not recommending it to start with here. You'd need application level coordination. There's no locking here. Let's just be clear, there's no locking, okay? In terms of consistency, it's going to come down to your network speed and reliability because it is event-based. But I did want to bring up this one thing that we've done. This is a compromise to get this release out, and that is directory consistency is implicit, and we're going to be building that other directory based on the path names of the parent directory ACLs. So essentially, you're not going to have your ACLs exactly matched, and you're not going to have some explicit directory work. And again, that was a compromise. I would imagine over time, we will get better at that. What this means is, if you have directories that are moving around, this initial service might not be for you. This would be more for static directories, right, and that sort of thing. And of course, in terms of ACLs, if you want to go in after the fact or during this process and modify the ACLs on the reader sites, you can do that. But in general, you can think of this as more, for static directory type operations initially. In terms of security, we didn't compromise there. Everything is encrypted. All artifacts are encrypted, or can be. Obviously, if you want to, you can turn those things off, but they can be encrypted. The other thing was, and this was the hardest thing we had to do, this is almost as hard as everything else, was dynamically adding readers and writers after the fact. If you have hundreds of millions of files, right, and you want to add a new reader in, you can't rely on the events. So we had to find a way to do something kind of like SOBAR, where you have to, catch up to these hundreds of millions of files. It has to be fast. We're working on that, and it's a very difficult problem. We thought of that, though, from a minimum viable product as something we would need, which is probably why you're not getting it in 5.0.1, is we felt like we needed to do that. We're actually quite a ways along on this, by the way, guys. And then in terms of intercluster, cluster down, failure tolerance, you can have your cluster down or your network down for a few days. If you go beyond that, then you hit the event horizon, and you're going to be having to use something more like a DR. We are going to support DR, with failover and whatnot. The other thing is again, this is a very loosely coupled thing. The management paradigm is your view is by cluster. So there's no centralized source like, something that's the master of all of these. Again, think of this in a multi-company environment. You're not going to be able to do that, right? So each cluster can do what is necessary and sufficient from itself. And it knows what it's writing and it knows what it's reading. And by doing so, you can, fit into this multi-site monitoring environment. Okay, so with that, I've kind of talked about some of our assumptions. Do you guys have any questions or comments on this service? Yes.
Rob, I'm assuming that all of this is also built on the fact that you can't then have stub files left behind or choose any type of small files to be left behind in the original file system. You're going to have to migrate everything by TC2.
If anything you want to share, you would need to migrate. So in other words, as a sharing service, you can decide whether or not you want to do it. But if you do want to share it, yes, it would need to be migrated.
So is there any sort of architectural design points for small file support or nothing yet?
There is nothing yet that we've done architecturally that helps with it, other than I would say the following. By doing the direct client access where every node in the cluster now does recalls, you can really go down that curve and still get actually pretty decent performance as long as your files are cool enough where you're not, churning the files. So the bottom line is that while architecturally we haven't done anything different, I think what you'll find is you go to direct client access, you can actually go down the curve from a megabyte down to smaller. I'm not saying you want to be doing, if your average size is 20 kbytes, this is for you, but you can start to cheat down that curve. We don't really have numbers yet for direct client access, but I think you can think of going down quite a ways.
So if your clients are going to be able to pull the data back directly, are you still putting a copy of that file back into the file system?
You don't have to, only on demand. So the thing is, it's a shared namespace. So you have stubs on all the sites, and then you have copies of the files where you want them. You can either by policy pull in just the stub or pull in the stub and the data on the reader sites, or you can wait for it on demand.
Yeah, well, can I ask a bit more on what Ray asked? In the simple case of a single G-Express cluster with a single object store, if the clients read a file that's been exported,
Yeah.
does that inherently put the files back in the file system and repopulate the disks in the MSD service?
Yeah, it does. In other words, it's just completely transparent.
Can you switch that off? So if you know that the client, because I had a request for that last week, because I had a multi-petabyte system, that's what we want to do. The clients want to be able to read the objects, but not repopulate the blocks in the file system.
So what, I don't quite understand. How do you read the file but not populate the files in the file system? I guess there's I'm
happy for it to go in the L1 from the client notes, not go back to the file system.
Okay, that's a new request. So, and the thing is with direct client access, we could do that. Ooh, see, this is why I go to these meetings. See, we have direct client access. So the point is we're already having this thing where we're bypassing everything. And so that should be pretty easy to do with direct client access. Let me write that. I'll write that down, and I'm going to talk to my guys, get back to you and see, what we could do. But the thing is, I'm telling you, I know how to do that.
Usually, by the way, it's multimedia, that's big multimedia files. They knew that the client was the only person who wanted the file, and they knew they didn't want to refill the file system.
Absolutely, and so with direct client access, we should absolutely be able to do that. But yeah, we'll look at it.
Okay, that's interesting because I think as a scientific institution point of view, I have clients talking about geographically shared data and object store. But they talk a lot about big volumes. And for us, big volume means normally tapes. Is tape something to fit somewhere in this future?
That gets asked from time to time. So if you think about it, we're an archive service. And so as a tier, we kind of fit, above things like flash, but kind of below things, above things like tape, but below flash, kind of a middle tier. So people say, well, gee, Rob, you work well with these top tiers. What happens if now my data is really cold, really cold, and I want to send it to tape? Or what happens if I have data on tape and I just want to get it off of tape and now I want to move it to object storage? Those are questions I get. Right now, we don't coexist nicely with Spectrum Archive. And the reason being that Spectrum Archive and TCT use a lot of the same stuff with, with LWE-DM API. We kind of get in the way of each other. So it's something we're definitely looking at and is coming up towards the top of the list. So in other words, if you look past multi-site support, when you get past that into next year, I would say that's one of the top things we need to work on next after this year. So the answer is right now, okay, so what can you do? What we can do, since they do need to be in separate file systems, is if you have a one-time move, what I would recommend is you pull it in and then you do a policy move over to another file system, and then it's in the one versus the other. And so it's, you kind of bridge them by an island policy. And I've actually seen a demo of that. I don't actually have a customer doing that. We did demo and did some proof of concepts around it. So I've seen it work. And if you think about how slow tape is and how slow object storage is, using in the middle, having that island policy, it's not going to be a big deal. I mean, it's not like it's going to tax your file system to do that policy move. The only question is, you really need to have your tape and your TCT absolutely needs to be in the same namespace. No, we can't do that yet.
I think, sorry, we're fine. So if you've got another question, Rob's around at lunchtime for you. Lunchtime as well, thanks. Thank you, Rob.